So you can see we can change this now, but the angle does not correspond correctly to the rotation value in degrees. This is why we need to convert this actually to radians before this is being transferred to this rotation socket. So you go to converter math node and set to the conversion to radians. And now if we put it to 0, you can see it's parallel with the knitting. If you go 90, it's actually at 90 degrees with this knit direction. And if you go to 180, it's parallel again, as it should be. Now we can rename this also to yarn twist angle, and copy this one and connect to the scale. And rename it to yarn plug. Just move these to these other ones. I have rearranged this a little bit in order to make more clear which group of nodes belong together. So we have so far connected these parameters. We will make now the rest of them. First we can change this one here, so which is actually the X spacing of the stitch. So let's input a value node and connect it to the socket here. The same goes for this group here. Now we can rename this to stitch X spacing. Next one, we can use this smooth maximum node to control the corners of the stitching, to make it more square-like or more round. So let's connect this also. Next one, we need a control for this angle. We're gonna use the same setup as we made here. So just copy this one here, input a new value, connect this here and this one there. The same goes for this other mapping node. Now what we are going to do is to make some effects to change the overall appearance of the knit shader. This will be done in between of these two nodes. At the beginning of our node system, we will add an effect for the heaviness of the yarn, which means basically how much little strands are sticking out, and we will make flexibility. It's kind of deformation of the knit when it covers different surfaces, right? It will stretch a bit. For that we need to add two color mix nodes, and we will connect the original coordinate system into the A socket here. And next we will add two noise textures. We will connect this vector in both of them and the color into the B socket of each mix color node. And we will connect the first color mix node into the A socket of the second. So this now means that the original coordinate system will be modified by this noise texture before it gets passed to the whole other stuff that we already have made here, to the nits, right? The modification is taking place twice. First, it's applying the flexibility, and second, it's applying the yarn hairiness. And this factor controls how much it influences that change. So if we put that to 0, there will be no change. And if we connect now this result into this vector, this should stay the same, which it does. And we can change the blending mode for both of these to linear lighting. The detail we will put to 0 because it's expensive on memory. And by changing this scale, we affect actually happens. We will put here something like 7 and here a 0.3. So we want to control this influence here. This will be done by the value nodes. So we connect one here. What we can do now, we can also put a value node to this scale vector node. So if we change now this yarn hairiness, actually we need to get a higher value here in order to it be even more finer. So here we have an overview of what we have so far. So you should also have a node setup that looks like this. So this is the first set of nits, and this is the second set of nits with the texture on them, and these are parameters that are affecting both of the groups. These are our values with which we are changing the parameters, and these are the flexibility and hairiness. We can change this a little bit that it looks more like a knit. So now if we combine our result from the maximum node with some image texture in a color mix node, put it into the B socket and the maximum value into the A socket. The blending mode is going to be soft light. So when we see the result here, you can see we have it's like a sharp edges. It's just being projected on the top of the knit shader, which basically means it's like printed on it. It's like printing on the fabric. But there's also a knitting procedure called jacquard, which means that actually every individual stitch can have its own color, which is different from the color of its neighbor stitch. So that means we need to tell Blender that every box in which one knit is being projected, we need one color value for each stitch. So let's do that now. We need to go to the beginning and modify the coordinates that are coming from here. For that we will need to combine X, Y, Z nodes for each group of knits, and we're going to connect from the separate XYZ node we're going to connect the X and Y values, and the same goes for this group down here. Next we need a vector math node, and we are going to select the snapping. What this does is that it rounds all decimal values to integer values. If you take a look at how this looks now, you can see that it's a gradient of values with decimals. But if we connect this to this snap node, we actually see that all values in between whole numbers are getting one value. This is exactly these chunks where the knit stitching is being defined. So this will exactly be our boxes for each color of the stitch. And the values that go inside here are actually the stitch X and Y spacing. So we need another XYZ connected to this one, to the increment, and use the maximum of the X and Y. So X, not the value, the maximum we need. So we need to do that also for the other group of stitches. So the maximum values of this go to X and this one to Y. And connect it here. If we now copy this image texture and plug in this vector in it and see what we get. So we are getting now different colors on different positions. In order to control the position and scale of this image texture, we are going to add a vector mapping node. And if we now modify the scale here, we see that actually we don't get yet the text that we had before, right? The Unkia logo, if you want. So this is because our UV space is not in the range from 0 to 1, because we have scaled it up with this scale here.